Happy morning, dear friends. Here's yours, Dr. Rajanta. Welcome to Demystify with Ajay. Dear friends, today in this episode, we are just going to discuss about image generation. Of course, there are so many papers are there within these 2 years. Yes, of course, it is all nearly 100 papers I just have collected related towards this image generation. Of course, surely we are just going to discuss everything, and whoever there in the research related towards this generation, yeah, you can just use this collection as like an back papers, and of course you can also uniquely create your research ideas and make use of it. Yes, thank you, dear friends. And of course, as we continue to push the frontier of AI, each new innovation brings us closer to a more integrated, efficient, and creative future. These papers highlight some of the most exciting advancement in multimodal system, 3D reconstructions, and image generation, transforming what we once thought possible and laying the foundation for the future of AI-driven creativity. And dear friends, you can find the full paper link in the description, and if you reference these papers in your research, make sure to cite it. Yes. The first paper we are going to discuss, it is all about planting a seed of vision in large language model. Dear friends, imagine a world where large language model can see and generate images simultaneously. Well, this is what the seed achieves. Seed is a novel image tokenizer that allows LLMs to work seamlessly with vision tasks. Traditionally, previous image tokenizers struggled with performance and were often slow to converge, but Seed tackles these problems head-on by designing image tokens that align with LLM's auto-regressive mechanism, where image patches are not confined to a 2D spatial arrangements, but instead follow a 1D causal dependency. So this makes it easier to integrate vision and language model. Difference, the key to Seed's success lies in its design principle. Of course, the token are independent of physical patch. Okay, physical patch position aligns with how LLMs process sequence. Difference, the token capture high-level semantic similar to work in a language model, ensuring efficient understanding and generation. By training a million of 5 million publicly available image text pairs in just 5.7 days using 64 GPUs. Seed transforms LLMs into powerful multimodal tool capable of text to image and image to text generation. This paper opens a path towards scalable multimodal training with improved image tokenizer, signaling a new era of multimodal AI system. Okay, next paper, it is all about distilling knowledge from text to image generative model. So improves of visual linguistic reasoning in clip. This explore exactly related to SDS clip, which is just specified here. Of course, I have just already given the exact paper. Dear friends, this exact innovation method improves clips, compositional reasoning capabilities, especially on tasks like Winogrand. This clip, a popular image, that is image to text model, excels at basic tasks like zero-shot classification. But it struggles when it comes to compositional reasoning. So where we need to understand relationship between objects and their attributes in complex scenario. Dear friends, the SDS clip solves this problem by using a distillation technique where clip is fine-tuned with knowledge from advanced text-to-image models. So like stable diffusion, so which are excellent at understanding non-vision language task. The core idea here is to guide clip learning through a differentiable image parameterization, so improving its reasoning without the need for massive retraining. And what about the result? Of course, dear friends, the SDS clip enhances clips performance on tasks like Winogrand by 7% and improves zero-shot capabilities across several datasets. So this show how distillation from a generative model can effectively extend the capabilities of existing image to text models and allowing them to handle more complex vision language challenge. Next paper, it is all about NU-MCC, that is Multiview Compressive coding with a neighborhood decoder and a Repulsive UDF. Let's dive into NU-MCC, an exciting breakthrough in 3D construction from single view inputs, where traditional methods often fall short. Dear friend, this MCC has been a pioneer achieving remarkable success by combining vision transformer with a large scale training. But even MCC has a limitation, particularly in handling large numbers of query points and recovering fine-grained 3D details. And yes, of course, this NU-MCC takes these challenge head on with two key innovation. Yes, the first one, it is all about neighborhood decoder. That is, instead of processing all points together, the system introduced center point as excellent proxies, allowing the model to focus only on the small neighborhood of query points. So this speeds up inference and enables better 3D texture recovery. And next, it is all about a repulsive unsigned distant function. That is what UDF. So unlike standard UDFs, which struggle with incomplete surface, so reconstructions, this new approach improves the quality of 3D object surface by filling in gap that other methods leave behind. And towards the result, yes, dear friends, NU-MCC improves upon MCC by 9.7% in terms of F1 score and runs over 5x faster, making it a game changer for real-time 3D reconstructions task. And of course, this paper marks a significant advancement in reconstructing detailed 3D models from limited data. Okay, next it is all about text to layer, that is layered image generation using latent diffusion model. Difference in text to layer, the author presents a novel approach to layered image generation, a process that allows user to generate and manipulate images at different levels or layers, like background, foreground, and object layers. So the layer compositing is essential in both professional and amateur image editing. So, and this paper makes it more efficient using latent diffusion model. And how it works? Yes, instead of gathering a single image, the system generates, of course, as I have already specified, the background, the foreground, and layer mask. The composed image built from these layers, so the magic happens with an auto encoder that reconstructs these layered images, training a diffusion model on their latent representation. So this allows for better composition workflow and the creation for more accurate layer masks than traditional segmentation method, so which often struggles with fine details. So the experimental results shows that text to layer produces high quality layered images, so setting a new benchmark for compositing task. So this method can change how we approach image editing, providing new avenues for creative workflows. And yes, dear friends, these groundbreaking advancements showcases the relentless progress AI is making in areas like multimodal understanding, 3D reconstructions, and generative creativity. Each paper represents a pivotal step towards realizing a future where AI doesn't just assist us, but opens up new worlds of imagination and potential. As these technologies continue to evolve, we can only imagine what new creation horizon will be unlocked. So stay tuned for more updates on the cutting edge of AI research, and don't forget to like, share and subscribe for future instant. So let us know your thoughts in the comments below, and if you come across any papers related to this topic discussed, feel free to share them with us too. Okay, thank you for watching and see you in the next episode. Happy learning, dear friends.